So for today's session, we have Mr. Abel Mathew, the CEO and co-founder of Backtrace.io. Just to give you a quick background about Backtrace and Unity signed the partnership in January this year, and the journey with Backtrace has been, very great. We have been able to cater to many clients, starting from gaming customers to non-gaming. With Backtrace, the developers actually gets a turnkey solution to capture, understand, and act on their game crashes, no matter the environment or the stage of development. And it's truly cross-platform and cross-engine. So I would start the session by handing over the session to Mr. Abel Mathew, and he'll walk us through the quick presentation about Backtrace, and he'll also show us the demo about Backtrace. In case of any questions that you have, you can mention your questions on the Q&A session, and we'll answer those towards end of the session. Thank you so much. Over to you, Abel.
Awesome. Thanks, Deepak, and good day to everyone else on the other side. So as Deepak mentioned, I'm Abel. I'm co-founder and CEO of Backtrace, where we're building a modern debugging and crash recording solution. I'm also an avid gamer myself. Counter-Strike 1.6 was when I began my addiction to first-person shooter games. Today, I wanted to do a couple of items. So the first is I wanted to actually present to you Backtrace as we present it to our end customers. And so when we think about our end users and when we think about the people that find Backtrace relevant, it's really around game programmers, system programmers, but it also includes infrastructure and tool programmers. Think about anyone as part of a central team, as well as QA folks and technical directors and engineering managers. That could be a producer, it could be a tech for an independent studio, it could be a tech director for a much larger studio. As well. And when people think about game crashes, not only as a game developer, but also as someone in the team of folks that are developing games, oftentimes it's important to reiterate why game crashes matter, and then really talk about best practices. And this is how the tool of Backtrace is really centered around. Throughout this presentation, I'm going to be splitting up what Backtrace is, and how we talk about it through kind of three core sets of best practices. And that's this idea of capture, investigate, and analysis, as well as how to process and how to manage the workflow around crashes. But when we talk about game crashes, there's a lot of terminology and there's a lot of things to really define when you talk about game crashes. The first most obvious way is that my game actually crashes. It goes away, there's a fatal error of some sort. With few exceptions, every game will crash in the wild. And that's without a doubt, whether it be the top AAAs to the smallest independent studios, even the best systems in the world, whether they be QA testing, will not catch all crashes. In fact, in one of the presentations I made a month ago with Fred, sorry, hearing some background noise. If the audience members don't mind muting, that would be great. One presentation that I made about a month ago was with Fred Gill at Respawn Studios, the makers of Apex Legends, Star Wars Fallen Jedi Order. And even he was telling me a large studio such as themselves, part of the EA family, was still dealing with crashes. And that's because crashes and hangs are inevitable. Additionally, when we talk about crashes, one thing to clarify here is that they don't just include a fatal error. They can include non-fatal exceptions and hangs as well. In the same solutions, methods, Backtrace can be applied to those non-fatal exceptions, hangs as well. Example, receiving a forbidden HTTP 403 response from an ad request, or someone integrating, Delta DNA and receiving an authentication error of some sort. All of those are what we include in the family of errors that we denote as crashes. And we tell folks and people who are developing games why to focus on crashes. And that's because the cost of fixing a crash is much less than the negative impact on your game. There's a reputational damage, especially if you're launching a game, that game, you only have, according to a number of studies, around 2 to 3 crashes before an overwhelming majority of the player base or the user base just stops playing your game, which leads to player churn. Additionally, those players will go on forums and they'll talk negatively about your games. Additionally, you're going to have your engineers running around frustrated by all of the crashes that are happening on their code base. Ultimately, game crashes leads to angry gamers, which leads to lost revenue, a bunch of haters on forums, and less successful games. In fact, this idea of software quality, game quality, equating to success in gaming, can be seen even with the biggest titles out there. Negative game review scores are directly correlated with lower immediate and long-term revenue, even for some of the biggest titles out there. Where you have games such as Grand Theft Auto, which has seen billions of revenue even within its first year. And the quality of the game was incredibly high, which you can see through things like the Metacritic score and the public perception. Whereas Anthem, spending over $100 million, but only generating around $100 million in first year of revenue. For a game and game studios, breaking even isn't going to cut it. They need to see those 5x multiples. So what can we do about crashes? And this is really where Backtrace comes in and where we've really centered our solution around. And the frustrating thing is that you can't just say, let's fix them. There's a whole myriad of complications and issues when dealing with crashes. So let's talk about best practices. The first is your ability to solve game crashes, game errors, is reliant upon your ability to capture the right data. When we then capture the right data, we need the tools necessary to be able to investigate that data and be able to do analysis on it. And then finally, it's the process and the management around dealing with those crashes. Best practices and solutions and the functional areas of Backtrace all focus on alleviating pain within these specific areas. Well, let's talk about capturing the right data. Having the right context to investigate and resolve the issue not only matters when you're in QA and testing, but it's also about getting the right data that really matters when it's happening in a release. So let me switch screens here, actually. When we talk about getting the right data, here is an example Unity issue. Now, getting the right data can mean a myriad of things. It can mean getting the actual exception error message. It could also mean getting attribute information, which type of system was this running on. The more data you have about the crash, the better off you are. And when you compare Backtrace, when you compare us to other solutions, this is one area where Backtrace really shines. It's this idea of capturing as much data as possible from the Unity engine, whether that be the call stack, the system that it's running on, but also custom attributes as well. And so what additional information can we gather that gives developers, give folks the context they need to be able to capture crashes? Additionally, with capturing the right data, it's also about capturing such things as attachments. In this example data, I don't have attachments, but here you can imagine attaching screenshots, video playback, which is an example of what we do on some platforms as well. And context also means context from other developers. So let's say I want to add a comment here for any other developer, anyone, any QA or testing folks that are also looking at this issue. Then I can simply, mention someone and then leave a comment here. Now, remember when we talked about crashes before, we were also talking about the idea of it not being non-fatal. Here's an example where this is a non-fatal crash, where I'm simply just logging an error. And so a key component of Backtrace is that you can log both non-fatal errors, logic bugs, etc., as well as crashes. And so here I'm just saying that I received a 403 forbidden, but then the game continues on. And it's really important to be able to capture these crashes because you may you may wonder down the road why my player stats aren't posting, or I'm seeing sporadic failures to those player stats. And being able to see this data from Backtrace and digging into this issue can be incredibly powerful as well. So the right data ultimately comes down to getting the actual call stack in the crash dump, being able to get such things as log files, what operating system it was running on, memory utilization, some idea of application version, internal game state like session ID, game ID. I go back to this here, back to this view. As you can see, we're also loading in information about the scene as well. So knowing which scene is where this error specifically happened can potentially point the developer to what the root cause might be, or some other insights that they may gather as well. Capturing this data is incredibly important, and a shining spot for Backtrace is our ability to capture all of this data. You can add custom attributes. You can also add attachments as well to be able to have the full context of the crash and being able to retrieve it in a moment's notice, being able to easily click on any URL as well. That's this idea of capture. And so as Deepak mentioned, actually before I move on, actually here. When we talk about capturing the right data, it means capturing the right data across all platforms, languages, and the like. And so whether that be Android and iOS, whether that be non-fatal crashes like ANRs, etc., whether that be PlayStation 4, Xbox, Stadia, Backtrace has integrations and the ability to capture data across all of those platforms. Additionally, it can be server-side applications. It can be even websites as well. You can capture that data within Backtrace. So once we have the right data, it's really about investigation and analysis. Has this error occurred in the past? Which crashes should I fix first? Which ones has the highest impact on users' gameplay experience? And this is a really powerful feature because once I have the right data, which a number of developers suffer from today, number of game studios don't get all of the information they need to be able to effectively solve their game crashes. But once you have that data, what can you do with that data? So this first idea of has this crash occurred in the past focuses on this notion of deduplication and grouping crashes together. It's a really powerful feature of Backtrace crash analysis in general. But once you're able to group crashes together, so are you able to see which crashes are similar to one another? Then there's this idea of aggregate analysis, finding patterns and assessing impact from a group of crashes. Actually, go to the second view here. And let me talk about crash grouping. So I'm going to remove this here. And what we're looking at is we're looking at a demo system with a game data from a Unity game. I'm looking at crashes over the last 7 days, and I'm only looking at crashes from version 3.0.0 of my game. Now, grouping crashes is our ability to say that I've seen 62 errors, but I'm grouping those into a single row because they are all similar. Crash deduplication or crash grouping, what happens is it groups these crashes based off of the data that's submitted. In many cases, it's the call stack from the actual issue, so where within the code the issue happened. But it can also be from such things as the exception code that was thrown as well. Now, when Backtrace groups these issues, now you can begin to understand and assess impact. But deduplication is incredibly hard, and it's a differentiating feature with Backtrace. For example, if I were to boil down and come and look at this issue here, do assert fail message. Now, if I look 2 rows down, do assert fail message is also down here as well. They are 2 different rows, so they're being identified as unique issues. But how come they're not the same issue? Many crash reporting systems, especially those built in-house or those publicly available, will simply just take the first frame within the call stack. Others will take the full call stack and then don't do any sort of intelligence on top of it to be able to group crashes more intelligently. In fact, if I look here, go filter 2, if my algorithm for grouping crashes is to simply just take the first frame, I have two crash groups right here that seemingly have very similar call stacks. But if I dig deeper and I actually go into the debug view here, I can see that these frames that led up to the actual site of the crash or the exception here are fundamentally different. And so they are grouped differently. And that's part of the power of Backtrace. And part of the thing to identify is the pain that people will feel when crashes that don't belong together are grouped together, and the pain that people will feel when crashes are not grouped together, but they are ultimately the same root cause. We can do this here. So crash grouping can be incredibly important. One of the ways that we talk about deduplication and crash grouping is this idea of taking similar errors and grouping them together. Now, deduplication removes the burden of analyzing each individual report. Going back to that same talk that I had with Fred at Apex Legends, when they started rolling out their own crash reporting solution, which is a common kind of discussion people will have, build versus buy. You know, why even use something like Backtrace when I can potentially build something like this myself? Well, the first iteration of Apex Legends crash reporting solution actually involved them manually looking at each individual report. You're not leveraging the power of crash deduplication, but crash deduplication is incredibly hard. And that's why, you know, just you can't do this in a night. You can't do this, you know, in a brief period of time. You actually have to think about the algorithm in which you're grouping crashes. These simplistic methods of grouping crashes have many, many downfalls. And so crash grouping is somewhere where we've spent a lot of time to be able to provide best in class, best in industry functionality. I'm going to skip over these slides for the sake of time to get some Q&A, but I want to focus on kind of the takeaways from crash grouping. The first is deduplication is important. You have to be able to group based off of the crash happening across multiple platforms, the presence of harmless or innocuous frames. And when you have the right crashes together, then you can begin to have tools for assessing impact and visualizing it. In fact, when later on in the presentation or in conversations, we can also talk about some of the advanced functionality around grouping here, where we can do recommendations based off of similarities of call stacks, based off of inner frames as well. Once we've grouped crashes together, then we can actually start doing analytics on these crashes. And when we talk to folks, game developers that are using Backtrace, users of the platform, it becomes immediately obvious that the way they prioritize crashes, the way they answer the question of which crashes should I fix first, is not as simple as which crash is happening the most. It's never really just which crashes are happening the most. It may also be which crashes are happening most recently. Or when you get to more sophisticated studios, it also becomes a question of, well, when within the game lifetime is this happening? Is this happening within the first 5 minutes of gameplay? You know, how loaded were the servers, etc. Prioritizing errors, or is this error happening on the newest version of the engine that we're running? We just upgraded the engine. I only care about fixing crashes that are coming from this new engine version, because ultimately we're going to shift everyone to that engine version. So prioritizing errors ultimately becomes now a function of which data you have and being able to do analysis on top of it. Those same data points also help investigation. But let's look at analysis first. So I'm pulling into the Backtrace system. And let me first describe what we're looking at here. I'm in the Explore view, which allows me to explore all of my data. It allows me to group errors and crashes by whatever attribute or metadata that's part of the system. So here I'm grouping by version, but I could easily group this as an example based off of Unity version as well. So only show me crashes from specific versions of the Unity engine. Going back to application version, so version of my specific game, I'm looking at crashes based off of the application version. And I am quickly seeing which devices were affected by this. You know, maybe in my testing system, I'm not collecting the device information, but I can see that crashes on 3.0.2 affected iPhone, Mac Pro, as well as a number of other systems, PC as well. We have 15 unique crash groups as part of this. We can see the distribution of scenes. So which scenes have I been seeing crashes or errors on? More importantly, how many unique users were affected here? When we think about this idea of assessing impact, the first thing I might do is I only care about the newest version. Show me crashes from the newest version. Or I only care about how many unique users were affected by crashes on this specific version as well. If I go back to this triage view, you can do the same type of prioritization as well. So for example, if I want to sort crashes by the number of errors or frequency, if I want to sort crashes by most recent, I can click here by activity as well. Or if I want to sort crashes by the number of unique users affected by that crash, then I can easily do that. Now, once I've sorted and prioritized this, we're going to actually go over this in a bit, but this idea of workflow and progress now allows me as a technical director to make sure that all of my top priority issues in this list are in progress. They're assigned to someone. They have a ticket associated with them as well. So this idea of prioritization immediately flows into the next steps of crash resolution as well. But before we go into that, there's also this idea of investigation and analytics. So if I go back to my Explore view, or if I pull up that view again, here I'm going to pull up a saved view that my team member has shared with me. But you can also pull up any view that any member of the team has. So I'm going to pull up his version dashboard v2. And one common way that people prioritize crashes is to ask how many crashes happened less than 300 seconds or 5 minutes within the gameplay. This is data that's automatically captured by Backtrace. And so you can see here that my latest version, I've actually fixed most of the startup issues. And back in 2.1.0, I had an overwhelmingly large amount of crashes that happened within the first 5 minutes of gameplay. This is a common KPI that game developers will use, especially AAA studios, because a crash happening within the first 5 minutes of gameplay can be incredibly detrimental to the gameplay experience. Now, when I'm looking at this, let's say I only want to look at crashes for this specific version, this idea of investigation comes out. So I'm going to filter to and only look at crashes from this specific application. And then I'm going to go to fingerprint. And fingerprint is the signature, or it's a way of showing me all the different crash groups. Now, for each of these individual crash groups, I can see how many users were affected. I can sort based off of this. I can also see the call stack associated with this as well. So I can easily retrieve context when I'm looking at these issues to be able to see and assess. In fact, I'm actually move this column. So which devices were affected, how many unique fingerprints are associated with this specific crash type. And then when I want to jump in, I can view latest trace. And that's the power of Backtrace, is being able to have this bird's eye view and then immediately jump into the details as well. We even have global annotations where I can see all of the game objects loaded. I can see such things as environment variables as well that may point me to more clues as to why the crash happened. When we think about investigation, it's centered around this idea of custom attributes, this metadata that we're talking about. So we have companies that use Backtrace where they'll put over 200, or hundreds of attributes on their crash reports. Everything from which scene was being played, to which area of the game level or the map was there, to such things as how much currency they had and game state and the like. All of those attributes can be easily added via our SDK in our library, as well as a number of things are by default collected, like the Unity version, operating system, etc., and the like. And again, it really boils down to, once you have the data, which is another key point of Backtrace, then being able to do analytics on top of it. A key story that we actually had from the folks at Respawn, and in fact, we've seen this a number of times with other companies, like, for example, Take-Two, who also uses Backtrace, is this idea that high priority does not necessarily mean the most frequent. Oftentimes, game crashes will happen because of exploits or cheaters. And so you may want to ignore those. And in fact, you may want to have a system that identifies those cheaters from the crashes and then blocks them. And so having that information can be incredibly important. And so this is a common pain point for folks. You know, oh, my crash system is overloaded because all I'm seeing is crashes from people who are trying to exploit my game. Or all I'm seeing is crashes where I can't do anything about it because it's a problem with the NVIDIA graphics card, etc. This idea of high priority not being the most frequent is a common one, especially when you try to look at hairy or nasty issues there. Server crashes are also important. So Backtrace also collects crashes from server-side applications as well. So if you're using something like multiplay or the like, Backtrace can capture those crashes. And they often impact several users at once. And so they can be incredibly high priority. One thing I wanted to show you back in the analytics view, so if I click here, now I'm looking at each individual crash. If I come back here and I look view latest trace, I can see that we have graphics name associated here. And so a common type of exploration or analytics we may do is for each of these crashes, show me the driver version. And so were they using Direct3D? Were they using OpenGL? And so I can immediately begin to assess, you know, is this crash exclusive to a specific driver and the like, or is it exclusive to a specific graphics card? These types of attributes are incredibly important when you're trying to really investigate and drive down into what the root cause is. Additionally, now we can now flow these analytics into better triage and investigation. And so that third point and value of Backtrace is really around process and workflow. Once I'm able to assess, you know, this is the highest impacting issue, I can go to my triage view, move my filters here, and say I want to see crashes that have only happened on you know, let's say equals, I'm going to do the latest version, so 3.0.2, only show me crashes that have occurred on that version, and sort by the, the highest value user. Now, workflow here is, as a technical director, making sure that a ticket is assigned to each of these issues, making sure they're in progress. In fact, as you see here, I have a crash that's affected 29 of my users over the last, look at the last 7 days here, and no one's on it, and I don't have a ticket associated with it. And in fact, someone who's initially looked at this said that this is a regression. So this is a flag for me to actually assign this to someone. So I can add, let's say, a Jira ticket or a ticket into other ticket management systems. I can assign someone to the user to be able to assign it to them so that they know, let's go ahead and start looking at this. And now what I can do, because I have this state within Backtrace, I can also say, you know, only show me, look here. When we have the state in Backtrace, what I can do is I can resolve and tell. So if as a developer, my workflow is, well, I fixed this issue, but it's happening on this version, it's going to stop on the next version. Then what I can do is I can resolve and tell, and until I see this crash in any version greater than 3.0.2, reopen the issue. So this as a technical director as well allows me to mute this issue and say, I've already fixed this, this will be fixed in the next version, and the like. Additionally, all of the, by looking at all of these items, you can quickly save these views as well. So if this is, let's say, a weekly dashboard that you all have, then you can quickly and easily pull this up. So looking at this workflow, this also contributes to my downstream systems as well. The Backtrace integrates into a number of different systems. We use Backtrace at Backtrace. So one of the key things that we do is we integrate it into where we chat and work. So one of the items here is Jira for ticket management, But we also integrate Backtrace into such things as Slack as well. So here I can pull up a number of integrations. So if we use Microsoft Teams, GitHub, we can send messages from Backtrace when critical crashes happen so that I'm immediately alerted or notified. This is just a sampling of the crashes, of the integrations. If you, there are many other integrations that you can integrate to, as well as a generic HTTP webhook as well. So this idea of workflow becomes incredibly important because it's, now that I have the data and I can investigate it, I can create intelligent workflows where I can be alerted now whenever a new crash happens on a specific version and the like. So these are the workflow integrations. While we're here, we can also see that there's a number of different settings and configuration items that people can configure. A key item of Backtrace is how turnkey and easy to use it is. So whether you're using Unity, whether you're using Unreal, whether you're integrating into Stadia, Xbox, etc., oftentimes it's point and click and a seamless integration into those applications, whether it be server side, application side, JavaScript, or the like. Very easy to integrate Backtrace into those applications. Additionally, for native crashes, things that come from PC or crashes that come from C++ code bases like Unreal games, we provide symbolication as well. And so this is the idea of uploading debug symbols. So let's say your iOS dsym files or your PDB files from a Windows game. Backtrace can easily handle those symbols by simply just uploading it into Backtrace. Additionally, what you can do is you can connect Backtrace to a symbol server. And this is also a key feature for a lot of people. When you're talking to studios, being able to easily integrate into integrate Backtrace into your symbol server, so we intelligently pull symbols. If you're unfamiliar with symbols, debug symbols would allow us to retrieve the source file and the line, the source file and the line number from the crash reports. So this allows us to easily give developers context as to where the crashes were happening. This is all centered around this idea of workflows and process. This idea of a turnkey plug-and-play system, so you don't have to maintain this yourself, or you don't have to use a hard-to-use or less functional system. Backtrace is just as easy to use as any other solution or anything that you can build, and it gives you far more powerful features. So much so that this is why the AAA game studios and the big game studios like Perfect World use Backtrace across a number of different titles as well. So when we talked about process management, we talked about currently assigning who's assigned to this issue and getting alerts and notifications of high impact items. So looking at this, building a better workflow, having seen a lot of these folks use Backtrace, is really centered around, first, not manually looking through all the issues, but setting up alerts and notifications so that if something's already in progress, don't alert the team, or alert someone if the next version of my game is starting to crash. You can route these messages to owners based off of context, and it allows you to log into a single system to be able to work through all of these issues very quickly. A better workflow does mean less wasted cycles. In fact, we had one game studio or game development company tell us that we were able to increase their efficiencies by mean time to detection by over 50% and mean time to response by over 90%, just by this better workflow, alerting, grouping, and being able to do analytics. So that concludes just the immediate demo of the system itself. I see there's a couple of questions here. So what I wanted to do was, and because a number of them revolve around Unity, I also wanted to show you how easy it is to integrate Backtrace into a Unity game. I'm pulling up Unity now, so just give me 1 second while it's opening up. The Backtrace is available as a Unity package. So you can easily download Backtrace by going either to within your Unity editor, which I'll show you in a second when it comes up, or being able to simply download the library from our open source GitHub page, github.com/backtracelabs. Here you can see our Unity plugin. And so you can easily download the Unity plugin and load it into your system. So now I have my Unity game up. And so this is just a very simple asteroid suitor that we have here. And one thing we can do is we can simply just load Backtrace as a package. And so what I've done here is I have the Backtrace package. And so you can use your normal package manager that's available to you within the Unity editor, and you can simply search for Backtrace, as well as I did before, go to the GitHub page, download it, and simply load it into your project. Now, all you have to do is drag and drop the Backtrace plugin. Once you've done this, now when you're working on your game, you can create a Backtrace configuration object. As you can see here, this comes up into the menu once you've loaded the plugin. You can start a configuration object. I have one here already, where we say which server URL or which instance of Backtrace do I want to submit this to. If I want to handle unhandled exceptions, so just as a keynote, Backtrace handles managed exceptions, unhandled exceptions, fatal errors, and the like. It's incredibly powerful when all you have to do is just integrate this plugin and you immediately get this crash reporting available to you. You can also do offline submission as well. So let's say you're developing a mobile phone game and you're worried about intermittent connectivity. So what Backtrace is able to do is submit this whenever you get that connectivity available. And in fact, you can keep that crash report around for an extended period of time. That way you can ensure that that crash report doesn't get lost as well. So when I load the Backtrace configuration, going back to my scene here, I can simply add the Backtrace component to it, and then I can load in the configuration file here. It has the URL configured, and I can get that URL very quickly by just going to Integration Guides, Unity, and it gives me the URL right here. You can simply just copy and paste that, and then I'm done. And so now, whenever I begin to play this game here, and whenever it submits errors, it will actually flow to this exact system that I'm looking at here as well. And so if I pull up most recent activity, this was some of the errors, some of the non-fatal errors that I was submitting from that example game that we're looking at just now. Great. So let me, I see some open questions and answers, so let me go ahead and quickly go through that while I have the screen up. So one question was, does it cover A&R crashes in Android? So if you, this is something currently being actively, developed. If you go to github.com/backtracelabs and Backtrace Android, you can see here, supports detection of A&Rs, application not responding. So you can easily just use our Backtrace Android library here available for this. I'd have to check if that, that same functionality is available within the Unity plugin as well. But the Backtrace Android plugin or SDK provides A&R support. The next question is, does it cover server-related issues to request timeout? So so if your server is based off of, let's say, Unity or one of these other languages, then it depends on how you report that request timeout. So as I said before, you can Backtrace can report issues, whether they're fatal or non-fatal as well. So if you see a request timeout, what you could do is you could explicitly send a report to Backtrace when you see that request timeout. You can do it, you can add your own logic to say, only do this every, 100 times, 10 times, etc. Additionally, you can, if it's server side as well, you can do the same type of logic. You can explicitly send a report. Explicitly sending these reports will still flow into the Backtrace system. If that request timeout does throw an exception and that exception isn't caught, then Backtrace will automatically push that exception report into the system. Next set of questions are any provisions to detect or report an AR, Android not responding, or application not responding. So I just went over this. What about iOS builds? As Unity, iOS builds has IL2 CPP code, which looks very difficult to understand how this tool helps us. So iOS builds we support. It's actually a good point around IL2 CPP. We're currently working with the Unity team to be able to get better data out of games that have IL2 CPP enabled. At the moment, this is still something that Backtrace doesn't translate from to an easily interpretable manner, but it's something we are working on with the Unity team. And timelines associated with that, we'll have to go back to the Unity team as we're still actively working with that. Is this tool also report non-fatal, non-handled or fatal exceptions? Yes, it does. Are you using any Google APIs to get ANRs? There's some level of interaction with the Android system to be able to get these ANRs as well. But I'd have to get back to you on the details as to which if any, Google-specific APIs are being used to get ANRs.
All right.
Any other questions? Sorry, go ahead.
Yeah, just wanted to ask the same. If people have any other questions. If not, you can always, drop an email to me. I think most of you have my email ID. I had sent the calendar request to everyone. And if you wish to, try out Backtrace, there's the link. And if you're stumbling anywhere, you can definitely reach out to me, and I'll be able to help you out. And
Absolutely.
Yeah, and I'll be sharing the recording of the session pretty soon. So you can always go back and share it with your teams also, specifically the QA teams, if you'd like them to, go through the presentation and through the recording. And we'll be happy to connect with you again. I think there are a few more questions, if I'm not wrong. Yeah, there's one more question which has come up.
I'm not familiar. Deepak, do you know what Unity CD stands for? Cloud Diagnostics?
I'm not really sure.
Cloud Diagnostics. Yeah. So at the moment, there are no plans to merge Cloud Diagnostics in this. So my understanding is that Backtrace is now kind of the preferred method to be able to work through your issues. And so because we have far more functionality, the idea is to now begin to use Backtrace instead of Cloud Diagnostics. Additionally, if you want to start a free trial, you can simply just click here, backtrace.io/create Unity, and that will start. You can simply fill this out and start a free 30-day trial to get up and running and easily using the system. As I mentioned before, going to the top right, project settings, you can easily get into all of the integration guides for all of the components that you have. Great. It's the end of this presentation.
Yeah.
Unless there's anything else, Deepak, I'm happy to.
I think that's it. And people can always reach out to us in case of any further questions. Thank you so much, for your time and with the presentation.
Yep. Thank you. Thanks, everyone.
Thanks, everyone, for joining this session. Please take care. Bye-bye.